Hey, eighth grade, how you doing? It's Mr. D. I know this is a rare role that you see me teaching in, but um, I know you're doing weather with Miss Lee, so I wanted to do a video about tornadoes and what causes them to be so massive. And in recent events, of course, we had the tornadoes this past weekend in Kentucky, which destroyed like whole towns. So, what I want to do is just do a quick tutorial here about how tornado grows in size and why some are more destructive than others. Okay. All right. So let's take a look at this. Now, what I did is I measured it, I put the tornado that you see here according to what they think how big the tornado was in Kentucky. So the tornado diameter here, as you see, 790 yards. That's equal to almost a half a mile because they think it was like a half a mile wide. All right. So I'm going to kind of, all right. So you see here, okay. Now, if this was now over here, this is the pressure difference. Now, what makes a tornado more destructive than others is there are several factors, but it's the biggest factor is air pressure. Okay, so let me describe some of this, what's going on. Okay, so and down here is the enhanced Fujita scale rating, which is how they measure the strength of tornadoes. So you can go anywhere from let me guess. You can go anywhere from, sorry, you can go from an EF0 to an EF5. Now, they're thinking that the tornadoes this past weekend were somewhere in this EF3 to EF5. So anywhere from between 136 miles per hour winds to over 200. So an EF5 is very rare. But you can see the destruction of an EF5. But really, what determines it is wind speed and then the damage. So, I mean, this weekend's tornadoes were somewhere in the neighborhood of, I mean, they were in devastating damage. I mean, people died, people's homes were destroyed, whole towns were gone. Whole towns are gone in Kentucky. So um, keep that in mind. It's sad. It's a really sad situation. Okay, so let's get back to the tornadoes. All right. So if this was an EF0 at this now pressure, now I'm going to kind of go back here. It doesn't matter so much the size of the tornado, it's the velocity, it's the speed of the winds, and it's the pressure difference. So if this was an EF0, if this tornado was 100 yards in diameter, meaning the size of a football field, and we had a pressure with a rotating speed of 65 miles per hour, this would be the damage. Okay. And as you can see, it would be damaging, but it wouldn't be devastating. Okay. It would just kind of cut a swath. And this is mostly because you have winds at in the upper atmosphere going in different directions. This is called wind shear. It's called vertical wind shear. And you have cold air, warm air, depending on how the outside temperature is, dew points, how humid it is. Okay, so there's a lot of factors there, like I said. All right. So what I'm going to do, I'm going to reset this. I'm going to reset this. Clear the screen. Sorry, I'm a little. I keep on hitting the wrong one. Okay. Hey, it's just like you were in history class. Okay. So I'm going to increase it to the size of the tornado that was hit Mayfield, Kentucky. All right. Now, if that tornado was an EF, if it's determined if it was, let's just say it was huge, but the pressure difference was not that great between what's in the inner core of the tornado and the outside pressure, this would be what the destruction would have been. Okay. So it would have cut a large swath. Okay. It would have caught, it would have maybe, so there would be some debris. There would be a little bit of a debris field, but it wouldn't be massive. Okay. Let's change that scenario. Oh, sorry. I want to clear the screen. Oh, I keep on hitting the wrong one. I'm doing this at 6:09 in the morning, you can tell. Okay. And I'm doing this all for you. Okay. So I'm going to increase, yeah. I'm going to increase the pressure. Okay. I'm going to increase. Now, they think the rotating speed of the winds was upwards of 170 miles per hour. Okay. So I've increased the pressure and I've increased the diameter, the width of the tornado. Let's reset this. Now watch. This is an EF4 now. Gone, 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 gone. So you can pretty much tell. Okay. So what we have here is we have the pressure difference between, and let me reset it so you can actually see the tornado. Okay. So the pressure difference between the core of the tornado inside and the outside pressure, air pressure, really determines the wind speed. Okay. So the greater this difference, the higher wind speeds, because now you have winds going in. That's called wind shear. You have different speeds. So at the surface, they may be low, but higher up, you're talking that the wind speed could be in excess of 100 miles per hour plus. So at the surface, you may have 60, all right, miles per hour, but up at the upper levels, you have a greater, because the air is it's violent, it's colliding, it's ramming it together. And also, you have what's called inflow. You have wind, warm air rising, right? Oh, I should actually make a different color. You have warm air rising, right, into the tornado if it's hot out or the dew points are high. And you have cold air depressing down, um, going into, it's called, it's going into the tornado. So you have these two air masses converging on one single point. Okay, and so that's going to cause major major problems. Let me show you an EF5. Okay, now watch this. You can have an EF5 wind speeds of 200 miles per hour plus, but a smaller tornado. I think I started it. Okay, so now I'm going to reset it. I'm going to show you the same. Now this is okay. So basically, you have the same destruction except a wider path because the tornado is larger. Okay, so really the size of the tornado does it. If it's smaller, you're going to have a smaller area of debris and debris field. If it's larger, you're going to have a larger area of debris field. And in the case of this weekend's tornadoes in Kentucky, you had a large tornado, you had a large difference in air pressure, and you had that explosive um, tornado. Now they probably think it's an EF. It's going to probably come in an EF4. Really doesn't matter, okay? Because at that point, I mean, violent, devastating damage. Yeah, you can just tell that. You could just tell that to the untrained meteorologist eye. Well, I hope this was good, and let me know what you thought. And if you have any questions, just ask. All right, Mr. D signing off. Adios.